This is the World Organic News for the week ending 8th of January 2018. John Moore reporting. This week we begin with a post from Science Daily entitled Speed Breeding Technique Sows Seed of New Green Revolution. This is great news given the apparent growing variability in climate conditions. Developing new varieties of staple products takes time, and this is usually the result of the generational time. So planting wheat in autumn, harvesting in late spring, early summer, analysis and then replanting, so 2 crops a year. The new system is explained. Quote, the speed breeding platform developed by teams at the John Innes Centre, University of Queensland, and at the University of Sydney uses a glasshouse or an artificial environment with enhanced lighting to create intense day-long regimes to speed up the search for better performing crops. Using the technique, the team has achieved wheat generation from seed to seed in just 8 weeks. These results appear today in Nature Plants. This means that it is now possible to grow as many as 6 generations of wheat every year, a 3-fold increase on the shuttle breeding techniques currently used by breeders and researchers. End quote. This is a big thing and provides great hope in the battle against things like renewed stem rust and similar new strains of old diseases. As the climate continues to increase in variability with increasing amounts of CO2, plant breeders are filling a critical role. Rather than throw chemicals at the problem, breeding resistant strains is a better long-term solution. This new technique provides the ability to breed these strains much more quickly. On the effect of climate change, the blog phys.org brings us the post predicting the effect of climate change on crop yields. Now with hybrid seeds, the industrial ag sector has produced plants that are almost identical. They mature at exactly the same time, require the same amounts of nutrients, and a standardised growing season. So you can see the problem. No 2 growing seasons are identical, and the variance of rainfall and storm events has been increasing this century. To that end, the University of Illinois are attempting to create better tools for predicting crop requirements. Quote, one class of crop models is agronomy-based and the other is embedded in climate models or Earth system models. They are developed for different purposes and applied at different scales, said Kai-Yu Guan, an environmental scientist at the University of Illinois and the principal investigator on the research. Because each has its own strengths and weaknesses, our simple idea is to combine the strength of both types of models to make a new crop model with improved prediction performance. End quote. This is an example of the things we need to ensure food production in changing conditions. In another piece from Science Daily, engineers make wearable sensors for plants enabling measurements of water use in crops. We see another example of this research being conducted. This quote from the summary of the article. Quote, scientists are developing graphene-based sensors on tape that can be attached to plants and can provide data to researchers and farmers about water use in crops. The technology could have many other applications, including sensors for biomedical diagnostics, for checking the structural integrity of buildings, for monitoring the environment, and, with modification, for testing crops for disease or pesticides. End quote. Having horticultural qualifications myself, I have an understanding of the water flow through plants, but to have actual real-time data would be amazing. Such information on water take-up would eliminate much water wastage. Water, of course, being a central requirement for life on this little planet, this engineering solution should bring huge savings. Whilst only applied to maize plants at present, the potential for use in other water-demanding plants is enormous. Linking water requirements to weather conditions, either El Nino or La Nina, could provide guides for all growers in a region, local microclimates notwithstanding. Eventually the tech should be widespread, but I can see incremental improvements bringing results quickly. There are times when relatively bare soil will be of benefit to researchers. This of course flies in the face of my 3 principles of no digging, no bare soil and no weeding. But there are places on Earth where with this condition of bare soils. Another post from Science Daily entitled In Antarctic Dry Valleys, Early Signs of Climate Change-Induced Shifts in Soil. Despite the huge amounts of ice, or more accurately perhaps because of the huge amounts of ice, Antarctica is the driest continent on the planet. But things are changing. Quote, in a study spanning 2 decades, a team of researchers led by Colorado State University found declining numbers of soil fauna, nematodes, and other animal species in the McMurdo Dry Valleys, one of the world's driest and coldest deserts. This discovery is attributed to climate change. which has triggered melting and thawing of ice in this desert since an uncharacteristically warm weather event back in 2001. End quote. A podcast footnote. Evolution is driven by changes in environment which creates new niches for organisms to exploit. Not all changes are slow enough for adaptations to occur. Think of things like the Permian-Triassic mass extinction, where some 96% of species were wiped out. Sometimes change is not good for life on Earth. End podcast footnote. It appears the changes in the McMurdo Dry valleys are not conducive to adaptation. True enough, those valleys are an extreme climate and life there is of a narrow sort. But could these declines in soil fauna be yet another canary in the mine shaft screaming gas, gas, gas with its last breath as the effects of excessive amounts of CO2 start to bite harder every year? I'll just leave that thought sitting there. While the above stories point to causes and responses to climate change, there are other areas where change of a positive nature is also underway. I've reported on the Elon Musk delivery of massive battery for South Australia's grid, but there are other projects going on across the globe. From the blog Grebe, that is, Generating Renewable Energy Business Enterprise, came the post, Island to test offshore floating wind concepts in Galway Bay. Quote, the test site, located 1.5 kilometres off the coast, will allow for the deployment and testing of a range of prototype marine renewable energy devices, innovative marine technologies and novel sensors. The facility will also provide access to the Smart Bay Observatory, allowing researchers and scientists to conduct research in the marine environment. The Marine Institute had operated a test site at the same location for 11 years until March 2017, generating a significant research knowledge base. The test site will provide researchers and those interested in developing ocean energy devices with an area in which they can test and demonstrate quarter-scale prototype ocean energy converters and related technologies. End quote. Given the location on the eastern edge of the Atlantic, some serious energy is available in both wind and oceanic kinetic forms. This is the sort of thing needed for areas where solar PV is not really an optimal solution. From the decentralised energy site comes the post, Myanmar attempts to bridge energy gap through off-grid projects. Here in Australia, huge amounts of capital are tied up in a gold-plated national grid, the cost of which is causing increases in electricity bills above and beyond the actual cost of power generation. Developing countries can sidestep this form of electrification rolled out across developed countries from the 1930s onwards. This is not dissimilar to mobile phone take-up in places like Nigeria, which mostly bypass the fixed landline technologies of the West. In Myanmar, and I quote, the World Bank is spearheading an off-grid energy strategy solution to help improve Myanmar's chronically underdeveloped power infrastructure. Kant Zor, Director General of the country's Department of Rural Development, says $90 million US would be used for the implementation of off-grid projects, which will run from 2016 to 2021. Upon completion, the project aims to implement solar energy home system in 8,400 villages and mini-grid projects to 350 villages that are situated over 10 miles away from the national grid. End quote. This means energy independence and freedom from the catastrophic blackouts South Australia suffered in 2016. Indeed, microgrids could be retrofitted to developed nations' macrogrids to create resilience within their systems. And with that pleasant thought, I'll finish for the week. A transcript is available at worldorganicnews.com. Thanks for listening. I'll be back at the same time next week.